In our last video, we introduced the notion of contradictory forms. Contradictory forms are those whose instances cannot be true at the same time. Also, from a pair of contradictories, one has to be true and the other one has to be false. So, in general, how do we find the contradictory of any given categorical form? Well, first of all, let's remember that the contradictory of a form is equivalent to its denial or negation. You will remember from our previous video that the contradictory of all dogs are fierce is some dogs are not fierce, or some dog is not fierce. Doesn't matter if it is plural or singular. Also, the denial of all dogs are fierce is simply not all dogs are fierce. Well, as you can see, not all dogs are fierce, and some dogs are not fierce, are completely interchangeable. They are equivalent, that is, they are true in exactly the same situations. So in general, not all S are P is equivalent to some S are not P, and the same goes for all the other forms. We also learned that we shade an area to indicate that the area is empty, and that we use an asterisk to indicate that the area is not empty. That is, the asterisk and the shading express opposite things, right? And so what can be affirmed with an asterisk can be denied with a shading, and vice versa. So the recipe for producing the denial of a categorical form is simply wherever there is an asterisk, replace it with a shaded area. And wherever there is a shaded area, replace it with an asterisk. Also, we know that the denial of a form is equivalent to its contradictory. So this procedure is also a procedure for finding the contradictory form. As an example, let's consider this diagram in which area 2 is shaded. So what is the contradictory of the categorical form represented by this diagram? Well, we simply replace the shading with an asterisk. Let's confirm that this procedure gave us the right result. The diagram to the right resulted from the diagram to the left by substitution of shading by an asterisk. That S is dogs and P is fierce. Which form is represented by the diagram to the left? Yes, it is no S are P, no dogs are fierce. And to the right, we have form I, right? Which is some dogs are fierce. And so we see that we have form E and form I, which are contradictory. So the procedure was correct. In our last video, we identified two pairs of contradictories, A and O, and E and I. So we can say that the truth of A entails the falsity of O, and vice versa. And completing the second line, the truth of E entails the falsity of I, and vice versa. Also, the pairs A and I and E and O are not contradictories. This means that A does not entail the falsity of I, and the same goes the other way around. Also, E does not entail the falsity of O, and O does not entail the falsity of E. Taking stocks in the relations among the forms, we have found that A and I, E and O, and I and O are not contradictories with ours, whereas A and O and E and I are contradictories. But so far, we have said nothing about A and E. Are they contradictory? For instance, all dogs are fierce, and no dogs are fierce. Are these two contradictories? Can this be true at the same time? Well, the answer may be strange, but we'll deal with this after a discussion of so-called existential commitment. For now, remember that contradictory forms, in their cases, one has to be true and the other one has to be false. It is impossible for all of them to be false, for both of them to be false at the same time. Now, is it possible for both A and E to be false at the same time? Well, yes, it is quite possible for both sentences to be false. In fact, that is the case, right? It is not true that all dogs are fierce, and it isn't true that no dog is fierce. So although both can be true at the same time, both can be false at the same time. So these pairs of sentences are what logicians used to call contraries. And the notion of a contrary is not the same as the notion of a contradictory. We'll keep on discussing this later.